Hi students, this is AJ sir. Let's study 10th standard ICSE Math, Chapter 22B, Heights and Distances, Part 2. Exercise 22B, question number 2. Find the height of a tree when it is found that on walking away from it 20 meters in a horizontal line through its base, the elevation of its top changes from 60 degrees to 30 degrees. Drawing the correct diagram is crucial to getting the sum right. The diagram would be like this one. Here we'll assume AB as the tree. Initially you were at some distance from the tree horizontally, and the angle of elevation was 60 degrees. Then you fancy to have a better view of the top of the tree. I don't know what caught your eye that you decided to go 20 meters farther away to get a better view, and now the angle of elevation is 30 degrees. And we have to find the height of the tree. So again we have two triangles here. We are going to find the values of CB and DB, and if we subtract them we should get DC. But DC is given as 20. So that's the logic behind solving this sum. First, in right triangle ADB, we will use tan, of course, opposite upon adjacent. Tan 30 is 1 upon root 3. AB's value we don't know, we have to find that. So keep it as it is. You could have used H as a variable, but I have chosen to keep it as AB. So you got the value of DB. Similarly, in right triangle ACB, you'll use tan 60, AB upon CB, cross multiply, substitute the value of tan 60 as root 3 and get the value of CB. You can rationalize it out here into root 3, but I'm going to do it later. I like to postpone things till the end. Now DC is DB minus CB. Substitute the two values which we've got, AB root 3 from here and AB upon root 3 from here. If you wish, you can give it equation number 1 and equation number 2 and write from 1 and 2. So now we have only one unknown variable, which is AB, which we will find. Remove AB common, you get root 3 minus 1 upon root 3. LCM, so into root 3 upon root 3, so the denominator is common, root 3. But root 3 into root 3, numerator becomes 3. 3 minus 1 is 2. 2 goes down, root 3 goes up, and we get this. It's good that root 3 is in the numerator, because dividing by 1.732 would be a headache. But multiplying is so easy. In fact, it's into 10, right? So just shift the decimal place, and that's the height of the tree. Not the heart of the tree, I said height of the tree. Next, the fourth sum. Mark it as IMP, but cancel Roman number 1. From the top of a lighthouse 100 meters high, so the height of the lighthouse is already given, the angles of depression of the two ships are 48 and 36 respectively. If they were on the same side, it would have been like this sum again, so I chose to cancel it. Let's do the other part where they are on the opposite sides of the lighthouse, and we have to find the distance between the two ships. So the diagram is like this. We'll assume AD as the lighthouse, 100 meters high. So we have to find BD from this triangle and find DC from this triangle, and just add it. So we'll find BC, which is the distance between the two ships. So in right triangle ABD, use tan 48. That's AD upon BD. Now we have to find BD. So if I cross multiply, BD goes up and tan 48 goes down. And we can find the value of tan 48 using the trigonometric tables. But dividing by a decimal number would be a headache again. So let's use one trick. First, I'll cross multiply. I won't substitute yet. BD is 100 upon tan 48. Yes, I've substituted the value of AD here. Is 100. Now, tan 48 is a reciprocal of tan 42. Remember this trick. Any tan value is a reciprocal of the tan of its complementary angle. Complementary means the sum should be 90. 48 plus 42 is 90. So this was 1 upon tan 48. It was in the denominator. I substituted it as tan 42 in the numerator. The beauty of this is, now after finding the value of tan 42 from the table, I have to multiply and not divide, which is so easy in this case. It's 100, so just shift the decimal place 2 places and I got 90.04. Now in right triangle ADC, tan 36 is AD upon DC. Even here tan 36 is in the denominator. Let's make it tan 54. So that multiplication is easy. And then distance between the ships, just add these two values and get the answer in meters. They've said up to 2 decimal places, so get the answer in 3 decimal places and then round off. In the fifth sum, there are 2 pillars of equal height. They stand on either side of a roadway, which is 150 meters wide. At some point in the road, the angle of elevations are 60 and 30 respectively. Okay, the diagram seems to be like this. So let AB is equal to CD is equal to H. That is the pillars. I'm going to assume it as H. In this triangle, I'm going to find the value of BP. And in this triangle, find the value of PD. Add them. That should be equal to 150. That's how we are going to find the value of H. So here, tan 60 is AB upon BP. Tan 60 is root 3. AB, we've assumed it as H. So cross multiply and get the value of BP. Similarly, in right triangle CPD, tan 30 is CD upon PD, tan 30 is 1 upon root 3, H upon PD, cross multiply, get the value of PD. Now BD is equal to BP plus PD. Substitute the values, take H common. By the way, BD is already given as 150, that's the width of the road. So now cross multiply. Here we have taken LCM, if you remember, and we get the answer of H as 37.5 into 1.732. We have to multiply this and we get the answer as 64.95 meters. But they've also asked us to find the position of the point. Where is it located? So if we can find BP or PD, either one of them, we can give the position of the point P from the pillar. Let's find BP. We already had a formula of BP. It's H upon root 3. So position of point P from pillar AB is H upon root 3. And H value, don't take the H value in decimals. That will be difficult to solve. Although you can try that, no problem. I'm going to use some other value for H. How about this one? The root 3, I guess, will get cancelled. So position of point from pillar AB is BP, which is H upon root 3, and H value I have substituted here. Root 3 gets cancelled, so I'm saved from all the trouble of calculation and I get the answer as 37.5 meters. There are many other ways to solve this sum. So if you wish to try it in another method, you can. Now question 7. The angle of elevation of the top of a tower is observed to be 60 degrees. At a point 30 meters vertically above the first point of observation, the elevation is 45 degrees. So we have to find Roman number 1, height of the tower, and Roman number 2, horizontal distance from the points of observation. So this is the diagram. AB is the tower. D is the original point of observation with angle of elevation as 60 degrees. And C is another point of observation which is 30 meters above D. And that gives us an angle of elevation of the top as 45 degrees. Roman number 1, we have to find the height of the tower. And Roman number 2, we have to find the distance of this observation points from the tower. One method is assume the height to be H entirely. Now EB is obviously 30 opposite sides of a rectangle, right? So AE will be H minus 30. So find the value of CE in this triangle. Find the value of DB in the big triangle using tan, of course, and solve further. But I'm not going to use that method. I will first solve Roman number 2. If you want to solve Roman number 1, go ahead, try it out. It'll be a good experience trying on your own. Even if you falter, you'll only learn from it. Do it. Now here, I'm going to assume CE or DB as X. That is the distance of the observation point from the tower. I'm going to find that first. And you have to write all the assumptions here. Also, CE is your construction, so mention that. Now, in this triangle CAE, I'm going to find tan 45, which is AE upon CE, and tan 45 is 1. It's an isosceles right angle triangle, right? So that means AE will also be equal to X. Okay, so far so good. Similarly, in triangle ADB, the big triangle, I will use tan 60 value and get the value of AB as X root 3. So this is similar to the previous sums we have done. I find AE, I find AB, AB minus AE is equal to EB, but EB is equal to 30, and that's how I'll find the value of X. So I took X common here, this went down, multiply with the conjugates, rationalize the denominator, so that it becomes 30 into root 3 plus 1 in the numerator, but at least the denominator gets rid of the root sign, the umbrella is gone, great. So that's upon 2. And root 3 plus 1 is nothing but 2.732. This is 15. So I get the value of X as 15 into 2.732. Remember, this is nothing but root 3 plus 1 in bracket. So it's 15 into root 3 plus 1. So what is X? It's the distance between the point and the tower, which comes out to be 40.98 meters. You have to literally multiply this. So do this. Don't copy. Practice the multiplication. Now I'll find Roman number 1, the height, which is AB. Now earlier somewhere I had found out AB. Here it is. It's X into root 3. And we have found the value of X. So you can find AB by multiplying 40.98 into 1.732. But multiplying the decimals will be quite a headache. So I'm going to use another way of calculating. X, as I said, was nothing but 15 into root 3 plus 1, which I substituted here into root 3. Open the brackets here. Then again open the brackets. So I got 15 into 3 plus 15 root 3. This becomes 45 into 15 into 1.732. So this multiplication is easier, and then addition, I get 70.98 meters. If you want to calculate in any other way, go ahead and do that. Next, the 9th sum. Mark it as IMP. The man on a cliff observes a boat at an angle of depression 30 degrees. The boat is sailing towards the shore to the point immediately beneath him. 3 minutes later, the angle of depression is just 60 degrees. How much more time will it take for it to reach the shore? And also we have to calculate the speed of the boat. The height of the cliff is given 500 meters. So this is the cliff. The cliff is not a mountain, it's just a vertical wall. Imagine it's a plateau out here. Okay, here is your friend waiting for you. Here we have the ocean. Here's your boat at point C. You are moving towards the shore. This is the shore. Maybe there's a beach out here. So after some time, you reach point D. That's after 3 minutes. How much more time will it take for you to reach the shore B? Initially, the angle of elevation was 30 degrees and now it is 60 degrees. When I say angle of elevation from point C, it is same as saying angle of depression from point A. So angle of depression for your friend is 30 degrees and later it is 60 degrees. Now the strategy here is we will find CB, then we'll find DB, and if we subtract it, we will get CD. And we know that CD was traveled in 3 minutes time. So using unitary method, we can find out how much time will it take to cover DB distance. And also, once we have the distance and the time, we can find the speed. So first of all, in right triangle ABC, the big triangle, we use tan 30, that's AB upon CB. Tan 30 is 1 upon root 3 and AB is 500. So we get the value of CB, which is 500 root 3. Don't substitute yet. In right triangle ADB, use tan 60, AB upon DB. Tan 60 is root 3, AB is 500. Get the value of DB. Don't substitute the root 3 value yet. Now CD is CB minus DB. Here we remove 500 common, LCM, and we get totally 1000 upon root 3. Notice how 3 minus 1 was 2 and 2 into 500 is 1000. So we got CD value. The distance CD is 1000 upon 3 meters. And how much time did it take for the boat to cover this distance? 3 minutes. Okay. So to cover this much distance, it took 3 minutes. So to cover the rest of the distance, that is BD, then only you can get to the shore, right? If you cover BD distance. To cover the rest of the distance BD, and yeah, we found earlier BD is 500 upon root 3, right? How much time will it be required? Cross multiply. This is unitary method. The best part is root 3 gets cancelled and we get the answer as 1.5 minutes. So that was easy. But Roman number 2, find the speed. Speed is equal to distance upon time. Let's use the distance of CD itself. 1000 upon root 3 meters. And the time was 3 minutes. Fine. But how do we solve this further? Well, denominators will come together. So it's 1000 upon root 3 into 3. And the unit should be meters per second. That's the SI unit. We never write speed in meters per minute. In the question they have mentioned find the answer in meters per second. So how do we convert minutes into seconds? Into 60 in the denominator, correct. But dividing by root 3 will be a headache, so just rationalize it now. Into root 3 into root 3. So this is what we get. After cutting and all, I'm left with this, and now there is no more tricks left up my sleeve. You have to multiply this first and then divide it. Or divide this first, get a decimal value and then multiply them. There is no other option. Don't copy from here. Do it. See if you're getting 3.21 meters per second. Then only you'll get full marks. So the sum was easy, but the calculation in the end was challenging. That's why it's IMP. Next, the 11th sum. A person standing on the bank of a river observes that the angle of elevation of the top of a tree. I don't know what you all are doing standing at the banks of rivers looking at trees instead of solving math. The angle of elevation is 60 degrees. When he moves 40 meters away from the bank, again the angle of elevation is 30 degrees. So this is very similar to the previous sum we have done, sum number 2. But I'm going to solve this in a different method, just to expose you to a variety of methods available in trigonometry. So here we'll assume TR as a tree. What's a coincidence here? And you were at Q, angle of elevation was 60 degrees. To get a better view, you went far away 40 meters to point P, and now the angle of elevation is 30 degrees. In this sum, I will assume the height to be H. I won't use TR, H. So in right triangle TQR, use tan 60 and get the value of QR in terms of H, which is H upon root 3. Similarly, in the big triangle now we'll get the value of RP and then we'll subtract it because that's 40, right? So in right triangle TPR, I'll use tan 30 and I'll get the value of PR. Now PQ is equal to PR minus QR, but PQ is already given as 40. The only unknown variable is H. first I did multiplying the whole equation by 3 so that my fraction disappeared, and this becomes 2h root 3. You can solve it the way you are comfortable. 2 goes down, root 3 goes down. Rationalize the denominator, so into 3 into 3. So you get 60 root 3 upon 3, which is 20 root 3. And the final answer for the height of the tree is 34.64 meters. But they've also asked for the width of the river. Now if you remember, you were at the bank of the river and the tree was on the other side of the river. So QR is the width of the river. How do I find QR? QR, if you remember, was nothing but h upon root 3. But h value, again, don't use a decimal value, use the root 3 value, because root 3 will cancel, and you'll find the width of the river as 30 or 20 meters. Now the 13th sum. The length of the shadow of a tower standing on level plane is found to be 2y meters, longer when the sun's altitude is 30 degrees than when it was 45 degrees. Let's understand this sum. This was a tower, AB. It has a height h, let's say. Initially, its angle of depression from the top was 45 degrees. It's also called the altitude of the sun, because the sun, no matter where it is, will make the same angle with the ground, 45 degrees. And when the sun's altitude decreased to 30 degrees, the sun is setting. Now it's at 30 degrees and always the angle is with the ground, right? Obviously the shadow is longer. When the sun is higher in the sky, the shadow is shorter. And when the sun is nearer to the horizon, the shadow is longer. And by how much is the shadow longer? 2y. It's given in the question, 2y. So now that we know the diagram, it's easy. Find dB, find CB, subtract it, and you'll get CD. So in right triangle ADB, use tan 45 to get the value of dB. Then in triangle ACB, use tan 30 to get the value of CB. Subtract it because CD's value is known, 2y. And here h common, we get this. I want h alone, so root 3 minus 1 goes down. Rationalize the denominator, use a conjugate. So the denominator becomes a minus b, a plus b, that's a square minus b square, that's 3 minus 1, 2. 2 gets cut, and we get what is asked. Now finally the 14th sum, mark it as IMP. An aeroplane flying horizontally 1 kilometers above the ground and going away from the observer is observed at an elevation of 60 degrees. But after 10 seconds, its elevation is 30 degrees. That's the angle of elevation. Find the speed of the aeroplane in kilometers per hour. First of all, why don't you try to draw the diagram on your own? Come on, this is the last sum. Let's see if you can get it right. Ready? This is the diagram. So this is the initial position of the aeroplane A, and it is moving towards the B, towards E. The height from the ground is fixed. It's 1 kilometer, that is 1000 meters. Initially there was an observer C. He was bored of watching trees, so he was watching the aeroplane flying away from him. Initially when the aeroplane was closer to him, the angle of elevation was 60 degrees, but as the aeroplane was far away from him, now the angle of elevation is just 30 degrees, obviously. We have to find the speed of the aeroplane now. It's amazing that a person standing on the ground and just measuring these angles and knowing at what height it is can calculate the speed of the aeroplane using trigonometry. That's the whole point of this chapter. It's very useful. So in triangle ACB, we will find CB. In triangle ECD, we will find CD. When we subtract it, we will get the value of BD. That is the distance traveled by the aeroplane. It's a rectangle, right? So it's equal. And This distance divided by the time, that is 10 seconds, will give us the speed. So that's the strategy of this sum. So tan 60 is used, which is root 3, and we get the value of CB. In right triangle AED, tan 30 is used. Keep looking at the diagram, always, don't just copy. That's 1 upon root 3, we get the value of CD. Now BD, that is the distance traveled by the aeroplane, is equal to CD minus CB. Substitute the values, 1000 is common, LCM, that becomes 2000 upon root 3, fine. And now the final step, speed. Speed is distance upon time. So note how I rationalize the denominator first. You could have done it later also, your choice. So distance upon time. This is in meters, by the way, and this is in seconds, meters per second. Fine. So 3 goes down, 3 into 10 here. Root 3 is nothing but 1.732, fine. But they want the answer in kilometers per hour. And how do we convert meters per second to kilometers per hour? Well, we have to multiply by 18 upon 5. That's right. That's how we convert meters per second to kilometers per hour. And if it was from kilometers per hour to meters per second, it would have been into 5 upon 18. Anyway, so here it's just normal multiplication division here. 3 zeros, so shift the decimal 3 places. First, I would like to get rid of the decimals. Any cutting is possible? Yeah, 3 ones are 3 6 are. That's it. Now you have been left with just multiplying this and dividing by 50. There is no other trick. Please calculate this. Check. Are you getting this exact answer? Are you good at multiplication division? This is a good opportunity for you to train yourself. Do it. Hi students. If you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.